notice that when you do the Z home, so if you feel them, you'll see they're kind of wobbly. And part of it is that it's really hard to get those lock nuts held, for one. Plus, you're riding on the bolt heads. You should be flat against the frame. So what we want to do is recess those bolt heads and go from there. Now, that doesn't address how easy it is to hold that thing. I think we can use the ones that don't have the nylon, because they're going to be easier to hold, and then just screw them in with a driver from the other side. But we would have to modify this piece or heat it to recess the bolt heads, because I mean, you can see it. I mean, for one it's that, and some of it is because it's riding on the bolt heads, which may be a little bit uneven too.
Isn't it a function also just of being not very thick, the plastic? Like,
Yeah. This piece, like what we're finding out is, yeah, you really need to do a solid job
Just
on that.
needs
So
to
probably
be
do like, well, first of all, we got 20%, so we can start by going to 100%.
okay.
And then modify.
We're 20%
Like-
of what?
We're 20% infill on all our prints, so it's
That would be
a
substantial.
lot of it is empty inside. So if you look at how it
There'll be
works,
so
when
much
you do the
material.
Z, so if you do the prepare, so it all's working, like, but look at how it moves. So say I move the Z axis down a little bit, you'll be able to see it.
Oh man, yours is keeping.
See how it, like one doesn't start off as good as the other?
Yeah.
Part of it is the belt tightness, other is like a little wobble at the bottom, you know? So
One still is.
So if we go, look at how it, now I'm going to try to auto home it. Look what happens when it does it. So that's XY auto home, and now when it hits it, it goes up, then goes down, and comes back up again. But look how it works. See, like it,
It goes.
yeah. So that all needs to be cleaned up for the prints to come out really nice and clean.
Yeah.
Now maybe if we do like a big tube kind of a thing, that would kind of come out in a wash.
Yeah.
Maybe, but yeah, we got to get that accuracy starting with the Z pieces. So we should probably start by, I guess one good thing would be to take those bolt holes there, just recess them,
So
recess the head.
we take the motors, we print better prints, and the other thing is the belts, but we can't do anything about
So
the belts.
about the belts,
Because this
I
one,
think,
look at this one.
No, but he's saying
way
he's
too
ordered.
big. Yeah, but it's gonna come.
yeah. Now on the belts, the other thing I noticed on belts, hey,
Hey.
um,
Hey there.
is when I tensioned it. So I used one tie, then another tie to get it more tension, and that's when I think it's still not super tight even, but I think that's because that motor ended up moving.
That's
you know?
one belt or two?
That's one. Here I got one. I just took off the other one because I mean to tension two of them, it's even a bigger mess. So,
Yeah.
but yeah, this is called GT2. Now the 2 stands for generation. So I was looking into this because this is all confusing. There's GT, GT2, GT3. The number actually stands for generation. It's the same geometry, but they start using different materials. So GT3 is like carbon fiber belted, which is like even stronger than GT2, iteration 2. But they come in different pitches. So the standard pitch here that all the 3D printers use is 2 millimeters. That's the spacing between the teeth. Now they have 3 millimeter and 5 millimeter. Now it turns out that the 5 millimeter pitch has about 30 times the belt, the tooth jump force, meaning it won't skip on a pulley for like 30 times more power. So, I mean, that's a persistent problem here with just skipping.
Incredibly.
So it's way, like if you get the other belt, but that means different pulleys, different belts,
Everything.
different everything. So we got to go through that because,
So
I
that's
mean,
where we have to go.
yeah, and this will completely work. I mean, with 30 times, that better work. And right now, with 0 weight, I mean, we don't have any issues going up and down. So like, you know, if we control, prepare,
I mean, I'm just saying too, like
move axis.
having all of our prints square to begin with. The
Well-
amount of like hassling to try and get them so that they're not friction filled.
Yeah,
That's all like
Quality
we're making it
prints.
better, but it's like there's so much human error in that even still that if it was machine accurate to begin with, we just I imagine it would be astoundingly better.
Oh, what do you mean by human error in which part?
Like we play with it to make it so it ends up more parallel, but like
Yeah, like
I'm
Yeah,
like,
but-
that's a complete like
But here's the deal.
putting
in
What
the
we do
air
is
kind of-
do things like put on a stop here, stop there, measure it very carefully, like on all four, and you bottom out to it. And same on these, you put stops, or even use like the physical
Yeah,
stop
no,
of the
that I
frame.
get for like leveling stuff. I'm just saying like for like ease of flow on the rails and stuff. Like I'm looking at this right here, and it's got like I don't know, it's almost
Yeah,
like 3.5, 4 degrees out of square, and like
right.
that's a lot of like stretching and moving around.
Sure.
And then I haven't stretched it to like accurate necessarily. I've stretched it to better.
Yes.
But like,
yes.
and then it's not necessarily square with the other one. And blah,
Yeah.
blah, and like,
And we should do the Pro,
that adds
which
up.
is more accurate on that. I mean, it's, man, like these universals, man, they are hard to get aligned.
they are.
Not easy. So the Pro is much better. Still, the it works is good. Yeah. But you got to do extra care. I mean, that's like expert level to get them all squared up.
But
Yeah,
like
it's
these
that's
new
precision
prints are
carpentry,
pretty
Yeah,
good,
it is.
You know.
right?
Hmm?
Those these new prints, like these
So
new
that's where we're at.
batches. Yeah, it's good.
We could do, but we could do like, we should just reprint all the pieces, like, make these things a little longer. Like, the part that makes it hard to move is like if you make them taller, yeah, they're gonna be a little easier to move because they can't bind as easily. The separation between the bearings is larger. But then again, we have to put in a spacer between the bearings or use like 3 bearings or something. So we have to make extra provisions for that. So this was like pretty cool for like quick prototype that actually moves around. But yeah, to get it perfected, we gotta take it up in quality.
And
But just starting with the 100% infill,
yeah,
that's gonna
exactly,
be like,
exactly.
That's gonna do so much.
like for
That's
example, these prints, they're 20%, 1.5 hours. For 100%, it's 2.5 hours. Yeah, so it's not too much more.
60%.
Yeah.
Can go 100, you know, those 60.
They're going 100.
Yeah,
Yeah,
that
it's
works.
100 right now.
Oh, yeah.
That's why it's like that.
Yeah.
So
You're the 100 guy.
Nice and filled, right? It's like how we print things.